Okay, so this video is going to talk about finding confidence intervals for when we know the population mean, but when the population standard deviation is not known. In this case, we'll need what they call the student t-distribution to calculate confidence interval. So again, practically, when we do a statistical study, the population standard deviation is not known. Okay, starting any statistical study. In fact, this is what happens in real life. Okay. So the question is, how do we estimate the population standard deviation, which is required in the calculation of the confidence interval? Remember, for when sigma, the population standard deviation is known, then we use this formula, right? So inherently, we need to know the population standard deviation, but like I said, we don't know that. So we actually, how do we estimate it then and use it to calculate a confidence interval? Well, we estimate the population variance by the sample variance, S squared. So remember, S squared is the sum of all measurement squared minus the mean squared over n minus 1. Sample mean squared. So in this case, the normalized random variable will follow a t-distribution with what they call n minus 1 degrees of freedom. So let me explain that in detail. So again, suppose we have a bunch of measurements taken randomly from a normal distribution. Okay, so in this case, we need to have the measurements taken from a normal distribution with mean mu and variance, with mean mu and variance sigma squared. So in fact, this is usually not known. Okay, this is not known. This is not known at the beginning. Then the random variable, normalized random variable x bar minus mu divided by s over square root n follows what they call a t-distribution, n minus 1 degrees of freedom. And the 100 times 1 minus alpha confidence interval on the true population mean will be given by this formula and highlighted in blue. Okay. X bar plus minus t alpha over 2 n minus 1 s over square root n, where again x bar is the sample mean. Okay, x bar is the usual sample mean. Now s is the sample standard deviation, which I've given the formula to at the beginning, right? This one right here. And n is the sample size. Now t alpha over 2n minus 1 behaves just like the z alpha over 2 for the confidence interval with normal distribution. But this is the t distribution. It's the value of t, independent variable of the t distribution, with n minus 1 degrees of freedom, such that the probability that this normalized variable falls in between these two values is 1 minus alpha. So you can see the picture as follows here. This is t alpha over 2, and this is minus t alpha over 2, with n minus 1 degrees of freedom. And the area to the right of this t alpha over 2 is alpha over 2. And the rest of the area in between, the unshaded region, is 1 minus alpha. Okay, so just a bit more information about this t distribution. So in fact, it just looks like the normal distribution, but with certain parameters. So nu here, okay, t nu here is the number of degrees of freedom. So we should mention here that nu is in fact just n minus 1. Nu is n minus 1. The degrees of freedom is n minus 1. So nu here is n minus 1. So some facts is that in fact tu, like I said before, is just like the normal distribution. It's bell-shaped, centered at 0. So each, like I said, tu is more spiral and flatter than the normal distribution. Okay. And so you can see here the picture here that the red curve here is just your normal distribution, but the rest of the T distribution is flatter, right? And more spread out. As nu increases, in fact, uh, so the spread of T nu decreases, and as nu goes to infinity, in fact, the T nu curve converges to the Z curve, the normal curve, standard